Here are all the supplies that we used in this video. Water, a bucket, tennis balls, and a tennis racket, but in our case, a badminton racket.
In this experiment, we will demonstrate gravity versus centripetal force. You will need a bucket, tennis ball, and water.
In this scene, we will place the tennis ball, which is on the left, and the water, which is on the right, inside the bucket and turn the bucket upside down. As you can see, the ball and water fell out. This is because the force of gravity acts upon both the ball and water, causing them to be pulled towards the ground. Now with the tennis ball and water still inside the bucket, we will swing the bucket in a vertical circle. As you can see, the tennis ball and water did not fall out and are still inside the bucket. This is because the centripetal force is greater than the force of gravity. The water is given a velocity and is forced into a circular path by the centripetal force exerted by the bottom of the bucket on the water. So as long as the bucket moves fast enough, the centripetal force of the bucket is needed to keep it going in a circle. And if the bucket is not going fast enough, gravity would be great enough to cause the ball and the water to fall out.
For our second experiment, we will be demonstrating Newton's second law with tennis.
You'll need a badminton racket and a tennis ball.
In the first scene, the ball is hit stopping only where her body is, leading to a smaller acceleration on the ball. However, when she follows all the way through with the tennis racket, the ball accelerates much more. Therefore, the more force exerted on the ball, the more it accelerates. When a tennis ball is hit with a tennis racket, a force is exerted on the ball by Newton's second law, force equals mass times acceleration. The weight of the ball is constant, so the force exerted onto the ball directly affects the acceleration as shown.